Okay, today we're going to be talking about graphing linear um, inequalities, and then we're going to talk about graphing absolute value inequalities. So we're going to look at the first example here. The linear one should look familiar to you from Algebra 1. The first thing I want to do here on this one is solve this equation for y. So I'm going to subtract the 10x from both sides. So I have y equals negative 10x, and I'm going to put it in front so that I'm in nice slope-intercept form. So I'm going to graph this line first. It's really a less than or equal to, sorry. But what I'm first going to do is graph the line y equals negative 10x minus 5. So that has a y-intercept of 5 and it has a slope of negative 10. So I could go down 10 and over 1, but it'd go off my graph. So I'm going to go up 10 and over 1 this way. Now, just like when we graph on the number line for interval notation, we have, and when we did the piecewise, we did the same thing. If we have an or equal to, we had a closed dot. Okay. If we don't have an or equal to, we had an open dot. Well, same thing here. If we have an or equal to, it means the points on the line are part of the solution. So we're going to use a solid line. If we didn't have an or equal to, we'd use a dashed line. So I'm going to get my ruler here. Oops, come back. And I'm just going to, so I can draw a straight line, because you guys know how bad I am at drawing straight lines, obviously. They become very crooked. I'm going to line it up with the 2 points, and I'm going to go ahead and draw my solid line. Okay, take my ruler away. Now, this is going to involve, remember, less thans have an infinite amount of solutions. So it's going to involve shading. So which side of the line do we shade? Well, we pick a test point on one side of the line. If you can pick 0, 0, that's the easiest test point. And I plug it into my equation. So is 0 less than or equal to negative 10 times 0 minus 5? So is 0 less than or equal to negative 5? And the answer to that question is no. 0 is not less than or equal to negative 5. So I don't shade the side with 0, 0. If that were a true statement, I'd shade the side with 0, 0. So I shade this side of the graph. Every point on this side of the line, including the points on the line, fit this equation, are solutions to this equation. Okay, let's look at another one. We'll change colors here a little bit. Now, you don't have to change everything to slope-intercept form if you don't want to. This is in what we call, so I showed you one where we could change it. I'll show you one in standard form that you don't have to necessarily convert to slope-intercept form. You can use x and y intercepts. So you can find the x-intercept. It's a little sloppy. You can find the x-intercept by substituting 0 for y. So this would read 6x is less than, well, we could just use the or equal to. Okay. Let's just pretend it's a line. Okay. So 6x is equal to 5. X is equal to 5, 6. So this crosses the x-axis at 5, 6. And then you could find your y-intercept by putting 0 in for x, and pretend like you're just graphing the line. So y equals negative 5, y equals 5, y equals negative 1. So it crosses the y-axis at negative 1. Okay, or you could put it in slope-intercept form and you'd get the same line. So now I'm going to go ahead and graph this But now this has, connect my 2 points here. This does not have an or equal to, so this is a dashed line. So we're going to dash our line like this. That means the points on the line are not part of the solution set. Okay, now we need to pick a test point. Again, I'm going to do 0, 0. I'm going to test 0, 0, and I'm going to put it back in my original equation. So is 6 times 0 minus 5 times 0 less than 5? So is 0 less than 5? Yes, 0 is less than 5. So this time I got a true statement. So I shade the side of the line that includes 0, 0. And that means all the points on this side of the line, not the points on the line because it's a dashed line, but all the points on this side of the line are solutions to that equation. Okay, so let's go ahead and move on to now what we know about absolute values. We're going to take what we know about absolute values and do the same thing. I don't have a symbol here, so let me make sure that we know that this one is less than, oh, that's pretty ugly, less than or equal to. Okay, so we'll do this one in this color. All right, so now what do we know about this absolute value graph? Well, it's the parent graph, but the parent graph is shifted, and it's shifted left 4, that's what that minus 4 does, and up 4. So that's what that plus 4 does. So remember our parent graph had a vertex. I'll just graph the parent graph really quick for you. Well, I don't want to graph the parent graph because it'll mess it up. But the parent graph, remember, goes through 0, 0, 1, 1, 2, 2, 0, negative 1, 1, negative 2, 2. So the point here that was 0, 0 goes left 4, 1, 2, 3, 4. Remember, the horizontal is opposite of what you think, and up 4. So it goes right here. Okay, and then this is really the only time you can use this trick. It's a little shortcut for the stretch. Okay, it only works in absolute values because they're linear. Don't ever do this in quadratics in a parabola. But the number in front sort of acts like the slope. Since the number in front is 1, I go up 1 over 1 this way, up 1 over 1 this way, up 1 over 1, up 1 over 1. This only works in absolute values. Never ever do this in quadratics. That's the way, basically this has no stretch. Okay, so now I'm going to go ahead and graph it. So I'm going to connect my points. And I'm going to start here. We know it's a V shape. Oh, and by the way, there's no or equal to, so this is going to be a dashed line. Okay, and then I'm going to go over here with my handy dandy ruler here. Line it up with my points. This is where sometimes it gets kind of hard. It doesn't want to line up with the points. Okay, and do a dashed line. Now in this case, you're either going to be shading inside the V shape or everything outside. So again, I'm going to pick a test point. I'm going to pick the test point 0, 0. So I'm going to plug it in here. Is 0 for y greater than 0 plus 4 in absolute value plus 4? Is 0 greater than 8? And that answer is no. 0 is not greater than 8, which means you don't shade. Since 0, 0 is outside of the V, you don't shade outside of the V. You shade all the points inside. And then that, all the points in there, not including the points on the lines themselves, are solutions to that inequality. Okay, one more. I'm going to show you again the trick with the stretch. Okay, so how does this differ with the parent graph? It's going to go right 3 because I have a minus 3. Okay, and it's going to go up by 2. And then I have a stretch of 3. So you can kind of pretend like the slope is actually plus or minus 3. And again, this only works in absolute values. Do not do this with quadratics. So my vertex that was at 0, 0 is going to go right 3 up 2. Okay, a stretch never affects the vertex. Now, here's where you can use the slope. So you can move the vertex. So now you can go up 1, 2, 3 over 1. Up, and then this way, up 1, 2, 3 over 1 this way. And you've applied the stretch. Now this one's going to be a solid line because I have an or equal to. So I'll line it up with my points. This one's going to be a solid line and a solid line. Okay, so there's my graph. Now I'm going to pick a test point. Again, I'm going to pick 0, 0. The only time you cannot pick 0, 0 is if 0, 0 is on your graph. If 0, 0 is on your graph, you cannot do it. You have to pick a point that's clearly on either side of your graph. So let's go ahead and do 0, 0. So is 0 less than or equal to 3 times 0 minus 3 plus 2? So that's 11. Oh, less than or equal to. So is 0 less than or equal to 11? And the answer to that question is yes. So since 0, 0 worked, we shade everything outside the absolute value graph forever and ever and ever. Every point out here is a solution to this equation. If not, you would have shaded inside the absolute value graph. So every point outside plus the points on the line are solutions to that equation. Okay, so hopefully that was a nice, short, easy lesson for you guys today. We will see you next time.